Just looking back at the Prac manual to see what we've actually measured with the oscilloscope. We connected the earth leads to point A, which connects back to the power supply. Point B was channel 1. So that means channel 1 displayed the voltage across the resistor, VR. Channel 2 was connected to point C, which means channel 2 displayed the voltage across the whole circuit. Now the voltage law says the voltage across the resistor plus the voltage across the capacitor equals the voltage across the whole lot. In AC circuit theory, we also have to take into account the phase difference between these. And so to represent that as a phasor diagram, there is the voltage across the resistor, there is the voltage across the capacitor, and there is the voltage across the whole circuit. What we have measured is V, VR, and the phase difference between them, theta. We've measured that on the oscilloscope. What you then need to calculate using your knowledge of trigonometry is the value of VC and the value of phi. Now in principle that should be a right angle, but we will not assume that. So go right back to things like the cosine rule and the sine rule to actually work out what that angle is, and then that angle to confirm that it comes out to 90 degrees. What you will also measure with a digital multimeter is just the voltages, and a digital multimeter can just measure voltage. So the digital multimeter with 3 separate readings measure the voltage across the resistor, the voltage across the capacitor, and the voltage across the entire circuit. And the way to interpret those results is you'll have measured VR, VC and V, and you need to use your knowledge of trigonometry to work out what the phase difference theta is and the phase difference phi is. And in the end, you'd simply need to compare the results that you get from measurements with the oscilloscope to the results you get with measurements with the digital multimeter. And just remember, what you have measured in terms of voltage with the oscilloscope is probably the amplitude of the voltage, whereas with the digital multimeter it tells you the RMS value. So you must remember to convert back from the amplitude of the voltage to the RMS value for the oscilloscope measurements.